Hey everybody, it's Jarrett, and this is going to be the second half to my All About Guitars preview. So this is going to be all about electric guitars. So what am I going to do? I'm going to talk to you about electric guitars and their subcategories as defined by their body construction, their neck to body joint construction, and then I'm going to walk you through the basic parts of a guitar, which for the most part, the parts should be the same for both acoustic and electric instruments. And then I will talk a little bit about the differences and similarities of how acoustic and electric guitars produce sound. Sound like fun? So let's get started. First, electric guitars and their subcategories. So electric guitars are often defined by the body of the instrument itself. So there are solid body instruments, there are semi-hollow body instruments, there are fully hollow body instruments, and there are archtop guitars. But archtop guitars are sometimes lumped in with the full hollow category because archtop guitars often are full hollow. More about that in a bit. Let's start with solid body electric guitars. Here is an excellent example. This is a Fender Stratocaster, specifically the Fender American edition of the Jeff Beck signature. At least that's how it started its life. You can probably tell I've made a few modifications to it myself. So it has a different pick guard, some different pickups, and a different bridge, and probably a few other surprises. So anyway, this is a solid body electric guitar. What does that mean? That means that this body of the guitar is solid wood. Now it can be one piece, or sometimes it's made from multiple pieces. Why would you do that, you might ask? The multiple pieces in a body might be due to cost, saving cost that is. It might be due to cosmetics, and then it might be due to sonics, and in some cases it's a little bit of all of the above. Modern Fender instruments are often made out of several pieces, like 1, 2, 3, maybe just one and two sides that are glued together like that. That's mostly due to cost saving, but you could also argue that maybe smaller pieces of wood that are really good quality and are very resonant when glued together would be better than one solid piece that has, knots in it and isn't very resonant. You could argue that. Gibson Les Paul, for example, has a maple top and a mahogany back, and that was due, Les Paul, the man who invented the guitar, partially, he wanted maple tops because of sonic reasons specifically. He thought a heavy, dense wood like maple would contribute to sustain, which is what he wanted to use a solid guitar in the first place for. Gibson later started realizing, hey, a maple top looks great if you put a transparent finish on it. So it's due to cosmetic reasons as well. Let's move on to semi-hollow body guitars. So a semi-hollow body guitar has this isn't one, this is still a solid body, but it has a top, it has a back, and it has sides like an acoustic guitar. But what's special about a semi-hollow is that it has a center block. It has a separate piece of solid wood that is in the middle of the guitar, and it's kind of glued and wedged together with all of those other pieces of wood. Now, why would you do that, you might ask? A center block, what it does is it might contribute to a brightness of the sound, it contributes to sustain, and it contributes to feedback resistance. So if you're playing an electric guitar in a room with a loud amplifier, that amplifier is producing sound waves, and then the body of your guitar is going to sympathetically vibrate, and that produces feedback, just as if you had a microphone held up in front of an amplifier or a PA system. So the center block helps reduce the stacking of those resonant frequencies. It also allows you to screw in a bridge or a more solid body style bridge, for example, into the top of the guitar. Let's move on to fully hollow. So a fully hollow instrument is going to have usually top, back, and sides separate and glued together like an acoustic guitar, but it's going to have electric style pickups put into it, not acoustic style pickups. unless it's maybe like a hybrid instrument, but let's not talk about special cases. Okay, and then an archtop guitar is similar, but the top will be arched, curved. There are, I think, some examples of fully hollow but not archtop electric instruments. For example, there's some versions of the Fender Telecaster that are completely hollow, not just semi-hollow, but they don't have an arch top to them, they're just flat. But a fully hollow archtop guitar, for example, the ES-175 by Gibson, it's a common example, it's going to have like the full arched top and arched back, like an acoustic instrument, but then it's going to have electric style pickups that are put into the top. There's other examples of arched top guitars which will still have an electric style pickup, but it might be floating. It might be attached to the pick guard, to the neck, so that it doesn't touch and weigh down the top of the guitar. Okay, other examples, just because I don't think I mentioned, so like a semi-hollow, a good example is the ES-335. Solid body, I mentioned the Fender Strat, which I have, Les Paul, etc. Okay, so that's the typical way to categorize electric guitars. Their construction: solid body, semi-hollow, hollow, maybe arch top, which could be combined with fully hollow. Another way that you can define electric guitars is by their neck-to-body attachment method. So this is what's called, this Fender Strat, this is what's called a bolt-on neck. It doesn't actually use bolts, that's a misnomer. There's lots of misnomers in the world of guitar. It uses screws, and these are wood screws. That does not mean that they're made out of wood. It means that they are designed to attach to wood, okay? So these 4 screws here, they screw directly into the wood of the neck. This neck plate, for all those of you interested in science and engineering out there, because it's attached to all screws, it increases the shearing resistance of all the screws. Look at how this neck is on here. The strings are in tension this way. So there might be a little bit of a pulling force, of a tension force vertically this way, but not much. So those screws, the screw threads don't really do all the work. What the work that they're doing is they're resisting this neck being pulled back into the body. And that would be a shearing force. This is shear. That would be tension. Okay, so these neck plates improve the resistance to shear. That's all I have to say about that. There's other designs, like you might have metal screws, metal set screws that go to a threaded insert in the neck. You can have designs that don't have a neck plate, but those usually have bushings of some type that also increase shearing resistance. Okay, another type, and I guess I'll switch guitars for this, another type is set neck. Let's gently put that Fender Stratocaster on the floor. This is a guitar design similar to a Les Paul, but kind of designed for jazz. A set neck means that, again, the body and neck are separate, but this is glued into place. There's no funky screws in the back. This is actually part of a strap lock system. So it's glued in, but they're separate. Another common type is called neck through. That means from here all the way to the back of the body here is one piece of wood, and then the sides of the guitar are just glued onto the side. Hence neck through, because it's all the way through the guitar. So those are there are other kinds of neck attachment methods. I've even seen a cool company who does it all with like antique wood joinery methods. They don't use any glue or anything. It's just a block of wood that kind of goes through and pins the joint together, and that's really cool. Anyway, but the most common types you're going to find are variations of bolt-on, which doesn't actually use bolts, set in, which just means glued, and neck through, which means that there's a center block that is the neck and the body sides are glued to the sides. All right, so I think I promised that I would talk about the different parts of a guitar. Most of them are common to both acoustic and electric instruments, and then discuss how acoustic and electric instruments produce sound. So let's pick up this Strat again and let's go through the main parts of a guitar, shall we? So I like to categorize guitars into 3 main parts. We have the headstock, we have the neck. They're attached, but I still categorize them differently because they serve different functions. Headstock, neck, and then body. So let's start with the headstock. The headstock is where You have your tuners, and you could separately, you could be more detailed and talk about the different parts of the tuners. For example, this is the tuning post, this is the tuning knob, key, peg, whichever. Maybe the post is the peg, I can't remember. Anyway, all of it together is the tuner. The strings wrap around and attach here to the post. That's where the string terminates. You turn this and it allows you to adjust the tuning of the string. These are also locking tuners that have this extra knurled knob on the back, which means that you can actually lock the string to the post. I could talk more about that in like a string set, putting strings on kind of video. Okay, headstock and tuners. Here we have the nut, which is where the string stops vibrating on the neck side, and it sets the distance of the strings side to side. Some guitars might have a fret on this side of the nut. It's called a 0 fret, but that's usually very modern guitars. Traditional guitars don't always have that. They usually don't. This is a roller nut. It has ball bearings inside to reduce friction. That's not important. The nut always functions the same no matter what the material is. Okay, this is the neck itself. This is the playing surface. So we have wood on the back. Usually a separate piece of wood on the top here. Sometimes it's one piece, but usually separate. And this wood piece on top is called a fretboard. It's called a fretboard because that's where the frets are. You could also call it a fingerboard because it's what your fingers touch. A violin has a fingerboard. It does not have a fretboard. Guitar has a fretboard that is a fingerboard. Make sense? If it has frets, you can also call it a fretboard. Because it's a separate piece, that makes it easy to put the truss rod, which I mentioned earlier. The truss rod strengthens the neck, and you would adjust it here. More about truss rods in probably a setup video. Let's just say for now it strengthens the neck for steel-stringed instruments. Then we get back here to the neck body joint, which, as I said, is a bolt-on with a neck plate on a Fender Strat. Here is the body of the guitar. This would be called the upper bout because oriented vertically, that would be upper. This is called, you guessed it, the lower bout of the guitar because when oriented vertically, it is lower. See how that works? These are called cutaways. A cutaway is a cut away in the wood, which allows easier access to the upper frets. This is a double cutaway because it has a cutaway here and here. The other guitar that I showed you, that jazz guitar, has a single cutaway. Acoustic guitars sometimes have none or sometimes have one. And occasionally you might have two, but that's pretty rare. Okay, so this is the body of the guitar. Some people might actually also call these horns. If someone says the upper horn, they're talking about the upper cutaway on the upper bout of the guitar. Here's the body, here's the strings, we already talked about that. This is the pick guard. Some guitars have a pick guard, some don't. Here are the electric pickups, I'll talk about that in a minute. Here are the electronic knobs, I'll talk about that in a minute. And this is a pickup selector switch. You select which pickup your amplifier is listening to, in effect. Here's the output jack. You call it an output jack because it's outputting a signal. Some people call it an input jack because you plug in a cable, but that's not, in my opinion, that's not technically correct. It's technically correct to call it an output jack because it's outputting a signal. This is a bridge. The bridge has saddles, which the strings actually go through. That means it stops the vibration at this point, and on an acoustic instrument, it would transfer that vibration to the body. Electric guitars do the same thing, but not to the same extent because they're all made out of very heavy metal. They transfer some of the vibration to the wood, but they also contain a lot of vibration in the string, which gives them more sustain. Okay, this bridge is commonly called by people a tremolo bridge, but that's not actually what it does, because tremolo is a variation in volume. And this actually produces a variation in pitch. You bend a bar and it lowers and can sometimes raise the pitch of the strings. A difference in pitch is called vibrato. So this is technically a vibrato bridge, even though not most people call it that. The Floyd Rose bridge is technically a vibrato bridge. It produces vibrato, a change in pitch. I'm telling you the correct terms so that classical musicians can stop making fun of us guitar players. Okay, let's get the right terminology going, guys and gals. So it's a vibrato bridge. The strings would go through here. There's also springs back here, which is how the vibrato bridge works. And that's about it. I'm going to talk a little bit about the difference between this and this jazz guitar, and then I'll talk about how acoustic and electric guitars produce sound. So this has a headstock, neck, and body. It's just the same, but these are non-locking tuners, and they're 3 per side tuners. It has a normal nut that does not have any ball bearings or anything in it. It has fretboard, it has a glued in neck, which is called set neck usually. It has one humbucker pickup, that means it has 2 coils that buck the hum 60 hertz, which is standard in America electrical systems. I could talk more about that later. This is a pick guard, but it's a jazz style pick guard, which is often called a finger rest because if you wanted, you could rest your fingers upon it. This is a fixed bridge, a Tune-o-matic style bridge, because Gibson designed the Tune-o-matic bridge and a lot of people copied it. It's a Tune-o-matic style fixed bridge. It screws into the top, and this is a stop bar tail piece that stops the strings. This is where you attach them. You can have other styles of tailpieces too, like a jazz floating tailpiece. Sometimes there's ones that are called a trapeze tailpiece. And here again are knobs. These knobs are passive. That means they only subtract information. If they were powered like an active system, then they could add information, but they're subtractive because they're passive. So that means when they're full up, it basically sounds like this pickup connected directly to your amplifier. So now let's talk about acoustic and electric guitars. How do they make sound? In both cases, what you're actually hearing is the string. The string vibrates at a certain frequency, and the air, the string transmits that information through the air, and then your ear picks it up and you hear it as sound. What the body of an acoustic guitar does is it basically amplifies that signal. So the string stops vibrating at the bridge saddles, and wherever the bridge is attached, that transfers energy to the body of the guitar. The body sympathetically vibrates, and that creates, both because of the wood itself and then the column of air which is trapped inside of the instrument, that produces more vibrations. The frequencies kind of stack up on each other and it produces more volume. Here's a trick that you can, just to show you how more wood mass vibrating amplifies anything. Take a solid body electric guitar and play it, and then just touch like your headstock or the body to a table and see what happens. It'll be louder. I almost always guarantee that. Okay, so how is an electric guitar different? It's basically an acoustic guitar with extra steps. So yes, there is some vibration of the body, and that does produce some sound in the room through the air, but what we want to do with an electric guitar is amplify it through an amplifier. So first, there's some sort of electronic pickup. These work on the principles of electromagnetism. That means they have a magnet, and that magnet is wrapped with copper wire. The magnet produces a magnetic field. Your strings are steel, so they're magnetic. They vibrate at a frequency, and that disturbs the magnetic field at the same frequency. That disturbance in the magnetic field produces an electric current in the copper wire with the same frequency of the string that started it all in the first place. And that signal travels, whichever, through wiring, through your knobs if you have them, and then to your output jack. Then you send that signal through a cable to an amplifier. What it does is it amplifies the signal. The signal is going to be a sine wave, and the amplifier is going to increase the amplitude, the distance between the peaks and valleys. Okay, and then that's going to be transformed back into the air via the speaker. The speaker is going to have a magnet and more copper around it that's going to take that signal and make the paper cone of the speaker move back and forth. And that's going to create vibrations, sound waves in the air, and then your ear's going to pick it up. Like I said, it's just an acoustic guitar with extra steps. What you're hearing is the string. You're hearing the frequencies of the string with your ears. Okay, I already talked way more than I thought I was going to. I guess I'm just having too much fun. But anyway, that was electric guitars, how they're categorized by their construction methods, the different parts of a guitar, and then how electric guitars and acoustic guitars produce sound in ways that are both similar and a little bit different. I hope I didn't forget anything that I wanted to talk about, but if you have any questions, you can, contact me anyway through comments or whatever, or email. Anyway, thanks a lot. This has been fun. Hope to see you around. I'm going to go practice now. Bye!